here we go. So this is reaching back a little bit, but when we do graphs by hand, we make a table.
Yes.
And what are the x values we typically use in our table?
0, 1, negative 1, negative 2.
Yeah, the numbers.
So we typically do -2 to +2. So last unit we were dealing with operations of rational functions, adding them, subtracting them, multiplying them, dividing them. Now we're going to deal with graphing them. So if you were to plug in -2, what would your y coordinate be? 1 divided by -2. 0.5. Negative or -1/2, right? 1 divided by -2 is -1/2. We good with that? What if you plug in -1? You get -1. 1 divided by -1 is -1. What about 1 divided by 0?
0.
Oh, be careful.
Wait.
1 divided by 0 is error.
I knew that.
1 divided by 1? 1 divided by 2? 1/2. So since we got an error for plugging in x, we have something in this unit called asymptotes. Does anyone know what an asymptote is? Okay, we're going to go. So asymptotes don't actually show up on the graph, but we draw them in as dotted lines. So they're imaginary lines. They're technically not there, but we like to draw them in so we can see where they would be. So we're going to have an asymptote. It's going to be a vertical line, so it's a vertical asymptote at 0. So I'm going to draw a dotted line on my y-axis because that's where x equals 0. All right, so I've got the point -2, -1/2. And I've got the point -1, -1. And if we were to plug in more points so we could see this, if you plug in -3, what do you get? If you plug in -3, what do you get? -1/3. If you plug in -4, what do you get? If you plug in -5, what do you get? So what's happening to these points?
You never get to 0.
Yeah, they get closer and closer. Are you ever actually going to hit 0?
Probably not.
Right, because if you plug in, like what happens if you plug in -100? Yeah, -1/100. What happens if you plug in 500? Yeah, it's gonna, but it's just never going to hit 0. Why is your fraction never going to get to 0?
The 1.
Yeah, the 1 on the top. So for a fraction to equal 0, you have to have a 0 on the top, and this one always has a 1 on the top. It will never have a 0 on the top. It always has a 1. So we actually have another asymptote on this graph, and that's at the x-axis. So we're going to draw a dotted line there as well.
And that's it's pretty much. What can you define it?
Yep. Okay, so the definition, we're going to write this right at the top of our page. The definition of an asymptote, it's ASYMP. The P is silent. Asymptote, we don't really say the P. TOTE. An asymptote.
That's not how it sounds.
Well, if you cover up the P, asymptote. The P is silent. Asymptote. An imaginary line that the curve gets closer and closer to. So a lot of math teachers first teach students, they say an asymptote is a line that you get close to but you never cross. And today that's what we'll see. But then we learn about asymptotes in more complicated math, and we learn that asymptotes can be crossed. You can cross it. And we learn that the actual definition of an asymptote is an imaginary line that your curve is getting, where the distance between the line and the curve is approaching 0. So I'm going to draw an example of an asymptote for you. We'll say, just so you can see what I'm talking about, we'll say here's our asymptote right here. And it's possible for the graph to go like this. So this is an example of a curve where it's crossing over the asymptote, and the curve is oscillating, it's going back and forth, but as you go forward throughout the curve, you find that the curve is getting closer and closer to the asymptote overall. Does that make sense? So in your head, don't think of an asymptote as a line you get close to but don't cross. Just think of an asymptote as a line that the curve is getting closer and closer and closer to. Okay? It might cross it as part of that, but it is getting closer to the line over time.
Multiple lines. Like multiple little
Well,
sections.
the curve itself is considered to be one line. It is one curve that just happens to go back and forth. Okay? So an asymptote is an imaginary line that your curve gets closer to. It might cross it, it might not. Today, our asymptotes do not get crossed. Later on in the unit, we will deal with asymptotes that we cross over. Okay? Does that make sense? When we go on throughout the unit, we're going to have asymptotes that might look like this. And we're going to find maybe our curve goes like down and it goes bloop, and then it gets closer and closer to the line. That's what we're going to see this unit. So we're going to cross over our asymptotes. We're not going to cross over like this. This is more like calculus problems. But in Math 3, we do see graphs like this. So we're not going to say that an asymptote is a line you can never cross. We're just going to say an asymptote is a line that you get closer to. Does that make sense? And it's imaginary. It doesn't actually show up. You wouldn't graph it. Although we typically do graph it, we graph it as a dotted line to show that it's imaginary, but I want to be able to see it. Okay, so we graphed the left half. We also have to graph the other half. So we've got the point 1, 1, and the point 2, 1/2. And the curve follows the asymptotes, like that. So that's one rational function. We've got another one over here. What's the difference between these two equations? It's got a squared. So what's going to happen to negative x values when you plug them in? They're going to become positive because you're squaring them. So we're going to use the same table. We're going to plug in -2, -1, 0, 1, and 2. And what happens when you plug in -2? You get 1/4. What happens when you plug in -1? You get 1. What happens when you plug in 0? Error. So what does that mean if we plug in 0 and get an error? What do we have? An asymptote. Okay, let's go ahead and draw it. And this is a vertical line, so we're calling this a vertical asymptote.
And it only becomes an asymptote when it's at 0, correct?
Mm-hmm. Yep. All right, what happens if you plug in 1? What happens if you plug in 2? 1/4. All right, so -2 up 1/4, -1 up 1. What happens if we plug in -3? (1/9). What happens if we plug in -4? 1/16. What happens if we plug in -5? 1/25. Okay, so what's happening as we plug in more and more points? We're getting closer to the line. Are we ever going to plug in a point that's going to make that fraction equal 0? No, not going to happen. So we have another asymptote at 0. So this one's horizontal. So our left curve goes like this. All right, and then our right curve, we have 1, 1, and we have 2, 1/4, and this one looks the same. So if you notice in both of our pictures, our curve is hugging the asymptote. It's getting closer and closer and closer to it. So when you have graphs that have asymptotes, you want to make sure that your curve is getting closer to them. If your curve is not, you drew it wrong. Alright, when kids get sloppy with these graphs, this is what I start to see. I start to see an asymptote that looks like this and an asymptote that looks like that. And then I see students drawing it like this and like this. Are those curves hugging the asymptote? No, they're pretty far away from it, right? Okay. So just be careful not to get sloppy as you draw your graphs. If you are drawing a sketch, if you're drawing a sketch just to get an idea, maybe to help you figure out the domain or range or something, that type of graph would be okay. But when I'm giving you a grid and I want you to draw the graph on the grid, then I want to see a fairly accurate picture. Okay? I want to see it getting real close. Okay, can we maybe put the food down for now? Because we're just a lot of wrappers, a lot of eating and chatting, and we're trying to take some notes. Just leave it on your desk. You can eat it in a little bit. Okay. All right, so now we're going to look through at some specific functions that have transformations. So if you guys remember, we have some transformations that show up inside parentheses. What are those transformations that are inside parentheses? Left and right. And then what are transformations that show up on the end of the function? Up and down. And what shows up in the front of the function? Stretch, compression, or reflect over the y-axis. All right. Now, there's not any parentheses on this problem, but if they did have parentheses written, they would have put them right here. They just didn't need them because the fraction kind of lets you see what's inside the function all on its own. So can you guys see what the transformations are for this function? Left 5. Yep, left 5. Down 3. So for us to be able to sketch a graph of this, we're going to take these points from our table and we're going to apply these two transformations to them. Okay, so I'm taking the point -2, -1/2, -1, -1, 0 error, 1, 1, 2, 1/2. So I need to move my points left 5. Does that happen to the x coordinate or the y coordinate? X coordinate. So if I'm moving it left 5, what should I do to the x coordinate? Subtract 5. So -2 becomes -7. -1 becomes -6. 0 becomes 1 becomes, and 2 becomes, all right, and then our last transformation is down 3. What does that happen to? The y value. So -7 stays the same. -1/2 is going to be -3.5. Yep. -1 becomes, error becomes, error stays an error. 1 becomes -2. 1/2 becomes -2.5. Okay. Does anyone know where the vertical asymptote is?
-5?
Yeah, it's at -5. So I can see that because that's where the error is, so I can't have x equals -5. So 1, 2, 3, 4, 5. Now, we have a horizontal asymptote here. It's just a little bit harder to find than the other one. Anyone know where the horizontal asymptote is? What number can y not equal? -3. Can anyone tell me maybe why the y-coordinate will never be -3 exactly? It is in the equation, you're right. It's not in the original equation. It's in the original though, look right here, we got a -3. So why is the y-coordinate never going to be exactly -3? Yeah, this fraction is never 0, right? The fraction has a 1 on top, so that fraction can never be 0. So that means you're always going to be adding a little bit or subtracting a little bit from -3. That means you can never exactly have -3. All right? So the number on the end helps you figure out what your horizontal asymptote is. We can never have that number because we're always adding a fraction to it or subtracting a fraction from it. So there's our horizontal asymptote. And I'm going to go ahead and fill those out right now. So my vertical asymptote was x equals -5. My horizontal asymptote was y equals -3. Okay. And now I can go ahead and graph my points. So I've got -7, -3.5. And -6, -4. And I've got -4, -2, and -3, -2.5. So the domain says what x values are you allowed to use? And I'm allowed to use all of the x values except for one of them. -5. So if you guys remember from last unit, how did we find excluded values when we were dealing with operations? We took the bottom. Yeah, so we would have said the bottom, the denominator, x plus 5 cannot equal 0. And then we minus the 5 over, we say x cannot equal -5. So last unit, when we were doing operations and we were finding our excluded values, we were actually figuring out the domain. We just didn't know that's what we were doing. So here we have an excluded value of -5. And on this unit, now that we're graphing them, that excluded value shows up as an asymptote. And the asymptotes tell you what your domain is. They also tell you what your range is. So here I'm going to say my domain is all the x values except for -5. Okay. So the way I'm going to write that with that special notation, if we say -infinity to +infinity, if we think about that, I've got a left arrow. What number is that? -infinity. And I have all the negative x's except for -5. So I'm going to say -infinity, comma -5. Should I put a bracket on that 5 or a parenthesis? Wait, can you equal -5? No, so it's a parenthesis. If you say, Miss Rice, put your finger on the point where it equals -5, I can't do it because it never does. Okay, so that's the left curve, -infinity up to -5. I'm going to put a U because I have 2 pieces to my answer. And then the right curve starts at -5. Should I put a bracket or a parenthesis? Parenthesis. And it goes to a right arrow, which is infinity. So it's kind of like saying go from -infinity to +infinity, but skip -5. That's what this notation is saying. Okay. How about the range? What's the y value that does not get touched? -3. So how do we write the range? We start from down, right? What's a down arrow?
Negative parentheses to -3.
-infinity to -3. Bracket or parentheses?
No bracket.
Can you equal -3?
No.
No, so parentheses. So that's the bottom curve, -infinity up to -3. And then what's the top curve tell us?
Positive infinity to -3.
So -3 to +infinity because we always go from down to up. Yeah. All right, I'm going to go ahead and draw this picture over here off to the side. I don't know why I made that a point. I meant to make it an arrow. Okay, here's what our graph looks like. If we put a little stick figure right here, What is the stick figure doing? Walking down, decreasing. Alright. And then we have our asymptote. Okay, so what was the x coordinate right here? X coordinate of an arrow going to the left? Negative infinity. What's the x coordinate at the asymptote?
Negative infinity.
At the asymptote?
Wait. Negative 3.
Wait.
Negative 5.
Negative 5. There we go. And then what's the x value over here? Infinity. Okay, so the stick figure, he's walking, he's decreasing. He decreases from negative infinity to negative 5, and then he falls down the dotted line, and he goes off into the abyss, and he dies. I don't know what happens to him. But we come up here, and we get a new stick figure.
Well, you just make him so brutal.
And what is this stick figure doing?
Running in half pipe.
He is decreasing as well. Alright, so we have 2 answers for decreasing. So what should I write for increasing? None. And my first answer for decreasing is what?
Negative infinity to negative 5.
Okay.
No bracket.
Yep, because these never have brackets, right? Alright, and then what's our second answer? Yeah, negative 5 to infinity. Alright. How do we find x-intercepts and y-intercepts? Calculator, we graph them. Alright. If you have a newer calculator, you're using a school calculator, or your calculator is not one of the old looking black ones, then you can hit alpha y equals to plug this in, plug it in as a fraction. If you have an older calculator, then you need to plug it in as 1 divided by, and then put the x plus 5 in parentheses.
So we do what you're doing?
So if you have a new calculator, do what I have for y1. If you have an old, you have a new one. If you have an old calculator, do what I did for y2. So everyone should be graphing it. Can anyone make a prediction about what you think the x-intercept is going to be? What number should the x-intercept be really close to? Negative 5, right? It's going to be a decimal. It's like negative 4 point something. It's going to be really, really close to negative 5. Okay. All right, let's go ahead and graph. Oh, I need to change my window.
It's a straight line.
Your window should be negative 10 to 10. And then 1, negative 10 to 10. That's a good window to use.
Watch that. It's all like that.
Negative 4.
All right, so I'm going to do second trace, option number 2. Left bound, press enter. Right bound, press enter.
The second trace.
All right. We're going to round this to 3 decimal places. So what should I write? Negative 4.667 comma 0. Okay. How do I find the y-intercept? Second trace. Number 1. Plug in. Yeah. If you don't like it when it gives you fractions like that, then you just have to plug your function in without using the fraction button. If you plug it in without using the fraction button, then when you find the y-intercept, it'll give you a decimal. So negative 2.8. So both of those answers are fine, but if you don't like the fraction, if you don't like it giving you a fraction as an answer, just don't plug your function in as a fraction, and then it won't give you any fractions. Okay, and it'll just give you all decimals. All right, go ahead and flip your page over. Can anyone guess for me what the vertical asymptote is?
Negative 2.
Close.
Oh, it's the square on the outside.
The square on the outside won't make a difference.
Did we skip the max and min?
Oh, max min. Alright, Maxman. Mountaintops, valleys. Do you see any mountaintops or valleys?
No.
Nope, the answer's none.
Wow.
That's why I skipped it, because we don't usually find them. Alright.
Usually.
Alright. Anyone know vertical asymptote, horizontal asymptote? Can you guess?
Would it be positive 2?
It's positive 2.
There's a negative on the outside?
Yeah, it's positive 2 because if you did positive 2 minus 2, you'd get 0. Right? Okay, so x cannot be 2, so that means we're going to have a vertical asymptote at positive 2.
Oh, it's okay.
Can anyone tell where the horizontal asymptote is? 4. Alright, we're going to make our table. So this table, it was negative 2, positive 1/4, negative 1, 1, 0 error, positive 1, and positive 2, 1/4. Okay. So I see 3 transformations. What transformations do you guys see?
Right 2.
Right 2, I heard reflect over x. And then what's the last one? Up 4. Okay, which one are we supposed to do first? Reflect over x. Okay, so in my table, I'm going to say reflect over x. Anyone remember what we do to the point if we're reflecting over x? We're taking something from up, moving it to down.
Multiply?
Up, down. We multiply the x or the y? X. No, we're going from up to down. The y. So if you're reflecting over x, you're going from up to down, and so that means you're making a vertical movement, which is the y coordinate. And we multiply it by negative 1. So this is going to be negative 2, negative 1/4, negative 1, negative 1, 0, error, 1, negative 1, 2, negative 4. Okay. Then we have to do right 2. So the first x coordinate should be 0, and then 1, and then 2, 3, 4. And then our other transformation is up 4. So if you have negative 1/4, and you add 4 to it, yeah, so it's 3 3/4. Right? You have negative 1 and you add 4 to it. Three. Error. You have negative 1 and you add 4 to it. That's going to give you 3 again. You have negative 1/4. You add 4 to it. That's going to give you the 3 3/4 again. Okay. So we are ready to graph our points. We have 0 and then 3 3/4. We've got 1, 3. We've got error, that's our asymptote. Then we've got 3, 3. And 4, 3 3/4. Yeah.
Can I see your pencil mark? Is that well?
No, because the... There we go.
Thank you.
So, the domain. It goes left forever.
Negative. Infinity.
Yep. And then, so it's going left forever. It comes up to the dotted line, which is at x equals 2. Parenthesis or bracket? Parenthesis. So we just did the left curve. The right curve starts at the dotted line. And it goes to infinity. Okay. Now this range is going to be different than the one on the front page. Does anyone know why the range is going to be different than the one on the front? So compare it. What's different about this picture? Yeah, you don't have one on the top and one on the bottom. Right? What do you have on this one? They're both on the bottom. They're side by side. They're both on the bottom. Okay. So if we look at our range, we start at the bottom. What number's an arrow going down?
Negative.
Negative infinity.
Yep.
And it goes up to the dotted line. 4. Does it go past the dotted line? No. So this one's done. So this range only has one part for the answer instead of 2 parts. Because the graph is only on the bottom side. I'm going to go ahead and draw my picture so I can find my increasing, decreasing. Yeah, I don't know how to do that. Alright. Here's my little stick figure dude. What's he doing? Decreasing. And then he falls down the dotted line, falls into the abyss, and dies. And then we need a new stick figure. And our new stick figure starts down here. And is increasing. Okay. So what is my x value at an arrow going to the left? Negative infinity. What is my x value at the dotted line? 2? That's 2. What's my x value at the right arrow? Infinity. Okay, so what is my answer for my increasing interval? 2 to infinity. And my decreasing is negative infinity to 2. And how many x-intercepts do I have? I've got 2 of them, and what number are they really close to? They're really close to 2. One's going to be slightly under 2. One's going to be slightly over 2. All right, so now we got to graph it. Make sure you type your negative before you do your fraction. Or you could put a negative 1 on top. That would work as well. Okay. All right, so we've got second trace, option number 2. Left bound, right bound. Oh, 1.5. All right. And the Y-intercept is? Okay. And then do we have a max or min? No. None. Not for these graphs. These graphs don't have mountaintops or valleys, so they're not going to have maxes or mins. Because it's a typical thing to ask for any graph. So it's okay to ask it, you're just going to say none a lot for this unit. All right, at the bottom of your page, I want you to add a couple more things. We are almost done. We are almost done. We're going to write y equals 2 over 3, parentheses, x plus 1 minus 6. All right, we're going to go ahead and write the transformations for this. And there are two transformations that are pretty easy that you should be able to get. It's not stretch.
Is it compressed?
It's compressed.
2/3.
Yeah, this is not the easy one, by the way. This is a hard one. So this is a compression because you have 2/3. You guys see that? 2 on the top, 3 on the bottom. So we're going to say compression of 2/3. Okay, now we have the easy ones. What are the easy ones? Which is down 6 and then left 1. Okay. All right, so what do you guys see for this one? Reflect over X. Okay, what else do you see? We got 7/3. What's that? Stretch. So that's a fraction that's bigger than 1, so that's why it's a stretch. What else do we see? Right, 4 of 1. Okay.